bolt hole circles that don't have any kind of a cheat way to get it. You have to use trig. I'm not going to teach trig, I'm just going to show you how to use it. It's a lot more simple than you think. We have here, we're going to do 5 bolt holes, and the radius is going to be 2 inches. You see here, this one here is 1, 2, 3, 4, 5, 6, 7, 8 squares away, and that is literally 2 inches actual size. Okay, so 5 holes, 360 degrees divided by 5 is 72 degrees, and then these are all the other angles. Right there it says sine is the distance from 0 in the y-axis. Cosine is the distance from 0 in the x-axis. So let's start with the sine of 72 degrees. And we know the radius. Let's say that the radius is 2 inches. So we multiply by 2. Whatever the radius is, you multiply it by. You multiply sine 72 by whatever your radius is, and it'll give you your coordinate in y. Let's do cosine of 72 degrees times 2 inches, and there's that's your xy coordinate. So literally, your cutter is above 0, 0 right here. Let's say this pencil is your cutter, and it's at 0, 0. You're going to look at your digital readout. You go up 1.902, and then you look at, and then you go in x. To the right, you go 0.618, and you drill a hole right there. That's actually where you drill a hole. Next one is 144 degrees. Same thing. Sine of 144 degrees times 2. And cosine 144 degrees times 2. Oh, I did that wrong. Times 2. There we go. Okay. So now we would go, for this hole we're going to drill, we would go up to 1.17, and we would go to the left, 1.61. From 0, you go up 1.17. 1, 2, 3, 4, you know that's 1 inch, so 1.17 inches is right there, and negative 1.618 inches. 1, 2, 3, 4, that's 1 inch. That's another half, and it's 1.618. So you can tell that that's right. You drill your hole right there. Here's the sine and cosine of 216 degrees times 2. Here's the cosine of 288. Sine and cosine of 288 degrees times 2. And there it is at 0 degrees, sine and cosine. And here you can really see. Okay, now I'm going to show you something else. I'm going to stop recording for a minute, and I'm going to show you something about the chord length right here, and how if you measure, if you had a 5-lug bolt pattern, you can't measure the diameter, because you have a bolt here, you go right across the diameter, there's no bolt. So I'm going to show you how to do that. You see that ruler. There's a 1-inch radius and a 2-inch radius. You can see that 4 squares is 1 inch, and each square is 0.25 of an inch. Okay, this is what I want to say. At this 1-inch radius, I got my compass, and it struck right through all those dots, those points that we put, and also the 2-inch, same thing. Now, these two are of interest here. Let's look at this point and this point. That's 144 degrees and 216 degrees. Let's look at sine only. Sine of 144 degrees times 2, we get 1.175. See, I have it there, 1.1755 y. That's the distance from 0 y. And the sine of 216 degrees. Times 2. It's negative 1.1755. I have that drawn here. That's the distance in y, again from 0y. So when you add those two together, you get this chord length is 2.351. That's this chord length. Now notice if we do the 1-inch radius, sine of 144 degrees, not times anything, we get 0.5877. There it is, 0.587 y. That's again distance from 0y. And sine of 216, not times anything, we get negative 0.587. There it is. And we know that that's the chord. When we add both of them together, we get that that chord measures 1.175. So you know that it's a little bit bigger than the radius, which is 1. So it's 1.175 radiuses, basically. And we flip that over, the reciprocal, 1 radius over 1 chord, 1 over 1.175 is equal to 0.85065 over 1. Now, if we didn't know this, and you had 5 lugs on your hub, and at this 2-inch one, you can't measure it, the diameter. It's an odd number. So you measure the chord length, and we get, so you measure this chord length right here, you get 2.351 inches. Now, knowing the ratio, we're using the smaller radius one for the ratio to 1. We know that the radius is 0.85065, the length of the chord. So we know the chord, so we just multiply 2.351 times the ratio is 0.85065. That's the radius to chord ratio, 0.85065. And we get the radius, 1.9998, it's 2. I didn't put all the digits in, or it would be 2. And we can see that the radius for this chord, in fact, is 2, right there. So you would know the radius by measuring. You would use the 1-inch radius to get the ratio, and then you can use that for whatever you measure. If this weren't a 2-inch radius here for this chord, it doesn't matter. If it were 3 inches, you would measure it and multiply it by the radius to chord ratio, and that would give you the radius for that. The radius for that particular chord that you measured. I made this 7-tooth sprocket that way. You see it fits the chain. And I did not use a digital readout, and I did not use a rotary table. I used all XY coordinates. It's a 7-tooth. I get the chain off of it. There we go. Yeah. And I was just drilling holes and then using a grinder. This is before I even had a mill. I used the drill press with, but I used a center. What's that called? You put in a lathe. Center drill. Center drill. Yeah. So yeah.